All right, guys, we're looking at the last video that we need to put together I need to put together this year for the GCC credit. All right, so the last topic we're talking about is finding the remaining trig function values. All right, so there's three things that we need here, all right, to be able to put this together. Well, probably more than three, but I'll write them down as they come to mind. All right, so the first thing is the Pythagorean triples. Now, this you don't need, but it'll save you some time. All right, so the first Pythagorean triple is 3, 4, 5. All right, the next Pythagorean triple is 6, 8, 10. All right, so you may ask, what does that mean? All right, so if three numbers are a Pythagorean triple, then they are the sides of a right triangle. All right, since the hypotenuse is the biggest side, then the 5 would be the hypotenuse and the 3 and the 4 would be the legs. All right, and the way that we know that this is a triple is because 3 squared plus 4 squared is equal to 5 squared. Right? 9 plus 16 is 25. 36 plus 64 is 100. All right, now there's more than just these two. All right, the next one is 5, 12, 13. All right, now I haven't done these in a while, so maybe my memory's off a little bit. So we're just going to check that, and I'm just going to show you. All right, well, I'm going to show you. I'm going to check and see if it works. So 5 squared is 25. So 5 squared plus 12 squared is 169, and 13 squared is 169. All right, so the memory didn't fail me completely. All right, the next Pythagorean triple is 8, 15, 17. All right, so 17 squared is 289. So 8 squared plus 15 squared, 289. Very good. Remember it again. All right, now the next couple here, when somebody told me that this was a triple, all right, he didn't actually show the calculations that I was doing, so I wasn't sure. Says, damn, 24 is so close to 25. How can that be? All right, but 7 squared plus 24 squared should be 625. Right, and it is. All right, and then 9, 40, 41. All right, as another Pythagorean triple. Okay, so basically what's going to happen in these questions is for some of them, not all of them, all right, but for some of them, you're going to be given two of the sides, maybe the hypotenuse, maybe one of the legs, maybe two of the legs. But depending on what you're given, you're going to need the triple to get the third side. All right, now, not every right triangle comes out as an integer. As a whole number. So you might actually have to do the a squared plus b squared equals c squared, right, to get the third side. My calculus professor in college caught me. He used the 3 and the 5, only he used the 5 as one of the legs. And I just said, oh, that's a 3, 4, 5. So I'm just going to assume that the 5 is a hypotenuse. Well, that was a bad assumption. I got that one wrong. So be careful. All right. So Pythagorean triples, we need that. All right. We need SOHCAHTOA. All right. That's why I did that earlier with reminding you about right triangle trig. Some old horse caught another horse taking oats away. Sine is the length of the opposite divided by the length of the hypotenuse. Cosine is the length of the adjacent divided by the length of the hypotenuse. And tangent of the angle is equal to the length of the opposite over the length of the adjacent. All right, so we're going to need that. all right, as we work through these questions. All right, and we're going to need the three graphs. All right, so sine looks like this. All right, remember, if I put the dots, it's okay if my artwork is off a little bit. All right, and that's -1 to 1 and 0, pi, and 2 pi. All right, so remember, between 0 and pi over 2, that's the first quadrant. All right, between pi over 2 and pi, that's the second quadrant, third quadrant, fourth quadrant. And what I'm going to need from these graphs is I need to be able to tell where the function is positive and where the function is negative. All right, so cosine looks like this. Well, patience. I'll get there. All right, so cosine starts at 1 and it ends at 1. Halfway through, it's at -1. A quarter of the way through and 3/4 of the way through, it's at 0. All right, so looking at that graph, I can see that cosine is positive in the first quadrant and the fourth quadrant, and it's negative in the second and third. All right, and then the third graph is y equals tangent x. All right, remember, those y labels are not as important because at pi over 2 and at 3 pi over 2, all right, tangent is undefined. In the first quadrant, it's positive. Second quadrant, negative. Third quadrant looks just like the first. And fourth quadrant looks just like the second. All right, so tangent is positive in 1 and 3, negative in 2 and 4. All right, so those are three things. I was remembering three things, but in the back of my mind, it seems like there's another one. I may have to come back here and add a little bit on those last three lines. All right, so first example, tangent theta. All right, theta is just a variable. It's like x and y. And tangent is 9 over 40. And theta is in the first quadrant. Find the remaining trig function values. Okay, I remembered what else I need to tell you. All right, so those lines aren't too far away. All right, so the main functions for trig are sine, cosine, and tangent. All right, the reciprocal functions. So for sine, the reciprocal is cosecant. For cosine, the reciprocal is secant. And for tangent, the reciprocal is cotangent. All right, so those are called reciprocal graphs. Now, the way I remember them, cotangent and tangent, that's kind of easy to remember. But for cosecant and secant, they don't start with the same letter as their original function. All right, so sine's reciprocal is cosecant, cosine's reciprocal is secant. All right, so I need to find all 6 trig function values. All right. So the question tells us that we are in the first quadrant. All right. So in the first quadrant, sine is positive, cosine is positive, and tangent is positive. All right, and the reciprocals are positive in the same quadrants where their regular function is positive, negative where their regular function is negative. All right, so they gave us 9 over 40. They gave us tangent. All right, so what we know is that there's a right triangle someplace, all right, with angle theta in it. It just can't be the right angle, all right? All right, and tangent is opposite over adjacent. So opposite over adjacent. Now, I totally understand that bothers somebody because I just wrote 9 next to a line that looks longer than the one I wrote 40 next to. That bothers some people, and some people it doesn't bother a bit. I'm just labeling the triangle. I happen to be in that second group and understand that not everybody's in the same group that I'm in. So if you really want to change that, just move theta to the top angle, and then you'll be okay. All right. So tangent is opposite over adjacent. It doesn't deal with the hypotenuse. If I go back to my triples, all right, the hypotenuse is 41. All right. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. All right, and as for the reciprocal graphs, I just take the regular function and flip the fraction. Okay, so it's as easy as that. All right, so example 2. I'm going to do one where it's not a triple. All right, so let's say if sine x equals negative 4/7 and x is in quadrant negative, so let's go with 3, all right, because sine is negative in 3, looking at the graph. All right, find the remaining trig function values. Okay, I'm going to do my triangle first this time. All right, I have angle X in it. Again, it doesn't matter where you put it. All right, I'm just going to use it on that lower right. It could be on the top, but it can't be the right angle. All right, so sine is opposite over hypotenuse. So opposite is 4, hypotenuse is 7. But I need to find the other leg before I can do all this. All right, so using a squared plus b squared equals c squared, wouldn't the last step be c is equal to the square root of 7 squared minus 4 squared? I know, somebody just said, where'd you get that, Mr. Benedict? Okay, I'll put it over here. Just a second. Okay, so it's not going to come out even. We're going to have a radical. So we've got, and we want to use the radical in the answers. So 4 squared plus b squared equals 7 squared. B squared equals 49 minus 16, which makes b radical 13. This little process that I did right here works well with the triples. If you don't remember the triples and you want to find out what they are, if they come out even, and that's only going to happen on a triple. All right, so this is radical 13. All right, so I've got sine, cosine, tangent. Doesn't start with the same letter, so cosecant, secant, and cotangent. All right, so we're in quadrant 3. So going back to our graphs, Quadrant 3, sine is negative, cosine is negative, but tangent is positive. Okay. And wherever the regular function is negative, its reciprocal will be negative. Okay. So sine is opposite over adjacent. We already knew that because that's the one they gave us, but it's always nice to do that and check it and make sure that it comes out right. It means you got your triangle set, right? Cosine is adjacent over hypotenuse, so radical 13 over 7. Right? Tangent is opposite over adjacent. And remember, we can't leave that radical in the denominator, so 4 radical 13 over 13. Remember, that is, right? We rationalize that as what it's called. You multiply it by a form of 1, that'll get rid of the radical. So top times top, numerator times numerator, and radical 13 times radical 13 is 13. Right? Square root of 169 is 13. All right, so now cosecant is a reciprocal of sine, so that's going to be 7/4. All right, that's going to be 7 radical 13 over 13, and radical 13 over 4. Okay, so like I said, they don't always use a triple, but when they do, all right, it's kind of easier, but it's doable without the triple too. All right, so got a couple of these I'm going to do, and then I'm going to leave you a couple to do for homework, and I will get that assignment up on Blackboard. Okay, so sine A is 3 over 5. All right, we got a right triangle with angle A in it. All right, and opposite is 3, hypotenuse is 5. Going back to our triples, we see that the other side is 4. Okay, angle A is in quadrant 1. So if you remember from the other side, in quadrant 1, everything is positive. So I've got sine A, I got cosine A, I got tangent A, and then the reciprocals don't start with the same letter, so cosecant A, secant A, and cotangent A. All right, they're all positive, which is good. All right, so sine is opposite over hypotenuse, and cosecant is its reciprocal. Cosine is adjacent over hypotenuse, and secant is its reciprocal. Tangent is opposite over adjacent, so 3 over 4, and cotangent is its reciprocal. All right, so hopefully they're getting a little better there. All right, and then let's take a look at, I'll do the one right below there. Now that's just like the one we did. So I'll do the cosine. Okay, so cosine B is negative 5 over 13. All right, so we'll do our right triangle first. All right, angle B is in that right triangle. Cosine is adjacent over hypotenuse. So adjacent is 5. Hypotenuse is 13. Remember, we don't worry about those negatives. That's just going to be determined by the quadrant we're in for the particular function. The length of a side of a triangle can never be negative. Right? So that's always going to be positive. Right? So going back to our triples, we see that the other leg is 12. All right, so find the remaining trig function values. Cosine, I hate it when I do that. Where's my magic whiteout tape here? About wearing this thing out. I like to always keep them in order. It's just easier for you guys to see it the same way. And it's easier for me to grade it when they're all in the same order. Yeah, I know. Somebody just said, oh, good, I'm going to mix them up just to mess with him. Shouldn't give you any ideas. You get enough as it is. All right. So we're in quadrant 2. So looking at the sine graph, all right, in quadrant 2, it's positive for sine. So sine and cosecant are positive. Cosine looks like this. So in the second quadrant, that's negative. Tangent in the second quadrant is also negative. All right, going back to those graphs. All right. So sine is opposite over hypotenuse, and cosecant is its reciprocal. Cosine is adjacent over hypotenuse, and secant is its reciprocal. Right? Tangent is opposite over adjacent, and cotangent is its reciprocal. All right, now, not meaning anything bad, but somebody just realized reciprocal means just flip the fraction. Okay, good. Better getting that now than not getting it at all. So, awesome. All right, so here we are. That is the last lesson that we have to do as we finish up the course for GCC this year. And hopefully that didn't go too badly, and you will be able to finish up that sheet and do well on the assignment. All right, have a good day, guys.